light emitting diode. So LED is a light emitting diode. So it is a PN junction diode. So if you take the PN junction diode, when it is forward biased, what will happen? There will be a electron hole recombination take place at the junction region. Because of the negative terminal, the more number of the majority's electrons are repelled and pushed towards the junction. And because of the positive terminal of the battery, more number of the holes in the p-type will be pushed towards the junction region. Due to the electron holes recombination, the energy is released, the photons is released. That is a light emitting diode. In some cases, in normal PN junction diode, during the electron hole recombination, heat energy is released. Here it is a light energy is released. Both are diodes, both are forward biased. So PN junction diode only forward biased. When the heat is released means normal PN junction diode. When the light energy is released means that is a light emitting diode. So this forward current, when the forward current increases, when the forward bias increases, what will happen? The forward current is also increases. Whenever the forward current increases, the intensity of the photon is also increases. Very simple, students. This is the p-type and this is the n-type. P-type conduction band and valence band, n-type conduction band and valence band. For the p-type, more number of the holes in valence band. For the n-type, more number of electrons in the conduction band. There will be a less number of electrons in the conduction band. There may be a less number of holes in the valence band for n-type, this p-type. Okay, so during the forward bias, what will happen? The holes and the electrons are pushed towards the junction region. In this junction region, then what will happen? There will be a electrons hole recombination take place. Electron hole recombination take place. At this time, if the light energy is released means that is a light emitting diode. If the heat energy is released means that is a normal PN junction diode. So this energy gap is Eg. E is equal to h nu. So energy gap E is equal to h nu. Instead of nu, C by lambda. So h C by lambda. So lambda comes here, Eg here means h C by Eg. So that is the wavelength of the light emitted, which is equal to h C by Eg. That is the energy gap between the conduction band and valence band in the PN junction diode. Then h is the Planck's constant, C is the velocity of light. So this is the VI characteristics of PN junction, that is a LED diode, PN junction LED diode. So initially what will happen? White color, then it will goes on, what will happen? Thick dark color we will obtain, green, yellow, red, like this. So this is the VI characteristics of PN junction diode. The symbol for PN junction diode is a normal diode symbol. You have to put the light, the photons are emitted like this, you have to put the symbol means this is the symbol for LED diode.